Evening, you guys. Well, here is a look at these odd power, like sine and cosine functions for a nice u substitution. We'll use it in two different contexts. So if you have an odd-powered trig function, sine or cosine, something pretty cool happens. You can actually bust that odd function up into one factor of that trig function, so you want to pull out a single sine x, and what's left behind is an even powered of the trig function. So this is the lowest form of that, sine cubed of x. So what we do is replace that sine squared of x with 1 minus cosine squared. So we have that great trig identity. You guys know cosine squared x plus sine squared x is equal to 1. And what we can do is manipulate that to do both sine squared and cosine squared. Doing that, and then u substitute using u is the cosine of x. It works out swimmingly. So here's u equals cosine of x. You know, du is negative sine x. And if that's the case, check this out. So negative sine x dx, by the way. This now can replace that one extra trig function, remember we pulled out in the beginning, that sine of x dx. And don't forget a negative sign that we pick up there as well. But that ends up being just 1 minus u squared. The sine of x dx is replaced with a negative du. And then it's a nice easy integral, just a polynomial. And here you can see the results of that. Don't forget c. And then when you put u back in, of course, u being cosine of x, you can just get cosine cubed over 3 minus cosine of x. So very clean, very cool. Now let me show you a little more complicated one. So now we're dealing with cosine to the 13th power of x. Same thing as you want to drag out one power of that function, that cosine of x dx right there. That leaves behind, if you think of it as cosine squared to the 6th, is the same thing as, sorry for the southern accent there, cosine squared to the 6th power is the same thing as cosine 12 to the 12th power of x. So that little cosine squared inside here we replace with 1 minus sine squared, now to the 6th power. The sine function now is our u, so if u equals sine of x, then we get du, of course, equal to cosine, and we have a deal, negative cosine, and hey, things are looking good, so negative cosine of x. So I take this cosine here, and by the way, dx on here, it's replaceable, in fact, with a negative du. If I take this negative over to the other side on the other function here. So I think you can see the u substitution, but this works every time you have an odd function. Just pull one power of that odd function out, make it even, and then you can make cosine or sine squared internally, factor out the proper power outside of that, and then you use u for whatever's left, 1 minus sine squared, 1 minus cosine squared. That sine or cosine becomes your u. The derivative of that will replace the other pieces by u substitution. And we're off and running. So this is going to be a nice little function. You can see the results of rewriting it after you go ahead and take it to the 6th power and expand it out. Now, won't have you doing any expansion of that size, but if you guys remember, Pascal's triangle can help with this type of expansion too, if you want to look that up again. But then once you get your antiderivative, you can put u right back in and get sine to the 13th of x13 and so on. Now, this is from Wolfram Demonstration Project, so if you guys want to look it up, you can actually see as you go higher in the powers. There's a pattern to this. You can kind of probably see it right now. We have odd numbers. They're descending at a certain rate. Look at the exponents here. They're the same for a while, and then, you know, there's some cool patterns you could pick up on and probably write something about it. But that's the general idea. Now let's talk about putting them together. Okay, so here's an example, you know, sine to the 6th power, cosine to 7th power of x, and we want to take that oddball, that cosine to the 7th power, you want to split out one of the cosines, so what you end up with, cosine sine 6th x, cosine to the 6th x, and there's that extra you just factored out. Now, this even powered one we're going to rewrite like we did in that last situation, and you get this little gem here, so that cosine squared then we replace with 1 minus sine squared, so we use sine to the 6th of x and 1 minus sine squared x to the 3rd now, cosine of x dx. This piece is our u, so u will be our sine of x that's left inside there. Du then is derivative of cosine is negative sine, so we have negative cosine x dx. And I'll just pass that negative over to the other side. So I can replace, again, if you notice, that's a pretty nice deal here. That cosine of x dx replaces all of that, and then anything sine related is u. So I got a lot of u's. So u equals sine of x I can replace there, and I get a u up here. So take a look at that. What you see is now we've got, if I expand out that 1 minus u squared to the third power, you can see that to the right there. That's a pretty nice looking function. Now all we have to do is distribute that u to the sixth throughout. We've got ourselves a totally integratable function. And of course now you can see, of course, that leaves you u to the 7th over 7 minus 3u to the 9th over 9. And you can see from there, we can simply put u back in there, which of course is our sine of x. So each one of these gets a nice sine of x. Oh, that's a blob. Let's not do that again. So sine of x goes into those, and we are home free. Hope that helps. That gives you the idea of the odd powered function. We would do that whatever your odd trig function is. This is if it's sine and cosine combination. This works. It can work in some other pairings, but this is the most often utilized. Email with questions.